Okay, so we'll go ahead and get started. So today we'll be examining some campaign finance data from the 2012 election, not from the current one, using Couchbase tools added in 4.5 and 4.6. So do want to make a quick note, we are using real data from the Federal Election Committee, and it is openly available. We'll be running a couple of queries, but our results are mainly for entertainment purposes. We didn't do a lot of detailed research. We just ran a bunch of queries and found some stuff that we thought you guys might find interesting. So during this presentation, we'll be taking a look at three tools in particular. First off, we'll be importing our campaign finance data with cbimport. We'll then be, so cbimport was added in 4.6. We'll then be examining the data using Couchbase Query Workbench, as well as showing off how to script queries using the Couchbase query shell. Both these last two features were added in 4.5. So first, we'll be taking a look at importing our election data with cbimport. So when getting started with Couchbase, one of the first things that many people want to do is import data into their cluster. In some cases, users have their own data sets that they want to use, and these data sets may be exports from another database, or they may just be data sets that were generated based on what they think their application will look like. In some other cases, users download pre-existing data sets in order to examine them or just to evaluate Couchbase for a project. So cbimport currently supports JSON, TSV, and CSV, and we allow users to either load data from local or remote locations. So users who already have their own data set, they can just load it locally. The data set just sits on their local machine. But we also allow users to specify HTTP URLs in case they're loading data that they find off of the internet. So one of the important and kind of cool features about cbimport is that since Couchbase requires every document has a key, we provide custom key generation in order to ensure that when you're importing your JSON data sets, you can create complex custom keys for every document. So in importing JSON, we allow a variety of different formats. First is a JSON document per line. Second is a list of JSON documents. And the third is the Couchbase samples format. So on the slide, you can see I've just put a couple examples. First two, fairly obvious. So object per line is the lines format. So you just have every document on a single line. List of objects is just a list of JSON objects inside of a JSON array. And this is usually what you most typically find, and it doesn't have to be on everything on a single line. It can be any particular valid JSON format. The last type is the JSON samples format, or the Couchbase samples format. And this is there's a JSON document in each file where the file name is the key name. One of the nice things about this is that you can actually specify index and view definitions. So when you load your data, you can do more than just loading the actual key value data. You can also create indexes and kind of get your cluster all ready to go. The downside to this format, though, is that it's mostly provided by Couchbase, so you won't really find this from other third parties. Another format or the other big thing that we support is separated value formats, such as CSV and TSV. You can specify really any separator that you want on the command line. So we allow more than just this. So you can separate by a bar. You can separate by any character. And then I won't go over these too much. I'm sure everybody's seen comma-separated files and tab-separated files. So we support all those. So one of the interesting features I mentioned is the key generation. So when importing data, you need to specify a key for each document. So specifying the key is done through a generator function. cbimport allows you to use custom generators like a monotonically incrementing value or a UUID generator. You can also use the values of fields in the documents that you're importing. So to specify a generator where you're doing field replacement, you just put the name of the field in between two % signs. To specify a generator function, you put the name of the generator function in between two hashes. So in the slide here, you can see we have a document that has two fields, name and age, and then we have a generator key, : name, which is going to be a field substitution, : and then mono inker. So if we run this against this document, then the result will be key : Alice : 1. And so Alice, because we've replaced what was in the name field, and then mono inker starts at 1. If we had another document, for example, was name, Barry, age 35, then the next value that would come out would be key : Barry : 2, and so forth. Okay, so I'm going to quickly just go through a quick example of how you can use this tool and show you what it looks like. So first off, if I just run the cbimport command, you'll see the cbimport function is kind of similar to the way Git functions in the fact that it has subcommands. So you can see we have the option to do either CSV or JSON. So if we look at the JSON in more detail, we have just some of the parameters that obviously need to define. You need to define the cluster, credentials, the bucket name, path to the data set you want to load. In the JSON example, you need to specify what format it's in, either sample, list, or lines, as we went over. You specify your key generator, the ability to do SSL, either skip verification or provide a CA cert. We provide the option to increase parallelism, so you can actually you can make the command run faster by having more clients that are connected to Couchbase, so it can load data quicker. The plus to this is it goes faster. The downside is it takes up more resources on the machine that you load the data from, as well as on Couchbase. So depending on where you're loading data to, you may want to adjust this parameter. We also provide an errors log. So if you've ever loaded large files, you may have found that one of the documents maybe isn't valid JSON, but you don't really want to skip loading everything just because of that one error. So if you have any errors in any of the JSON, it will just push that to the errors log if it's specified. And then the other thing that gets pushed to the error log are if it can't generate a key. So with JSON, you can have fields that sometimes are there, sometimes aren't. So if the field doesn't exist and we need it to generate a key, then we'll push that JSON to the errors log too. One of the other things to note also is, so what I just showed is the short help, and you can also get that if you just type -h. But one of the things that's new to a lot of the newer command line tools that we're putting out, we're also trying to update our older command line tools, is we're including manual pages if you run --help. So basically everything that I've just talked about here, you have more information about parameters, the data set formats, the way you format the host name, the key generators, and examples. So all of this information you should now be able to find whenever you use any of our newer tools. So quickly just show CSV command. So a lot of the same parameters here. You'll notice that when you load CSV, of course, you don't have to specify a specific format, but you can specify a field separator. By default, it's a comma. And then two other parameters in this that I think are interesting to know about. Infer types, which we'll be using in a minute when we show you actually loading the campaign finance data. So what's important about this is when you load a CSV document, everything is a string. And oftentimes you don't want everything to be a string, you have numbers in there. So if you specify infer types, it will automatically check each field to see if it's a number or a Boolean or a string or a float and load it properly. Omit empty is also here. If you have any empty fields in your CSV, since we're a JSON data store, you can just omit that field from the document. So this will lower the document size in some cases, depending on whether or not you want to use that. So the data set that we'll be working with today is campaign expenditures. And I'm not going to spend too much time kind of running through this, but the one thing that I am going to point out is we are going to specify a key generator using the candidate ID. When Eben comes up in a minute to show Query Workbench, he'll show you some of the tools that help you actually kind of see more about what your data looks like. I'm just going to copy a command here really quick. So as you can see, so we're importing CSV data. So we're importing CSV data, obviously specify username and password. We've specified infer types. And then, so the one thing that's interesting is here, so you can see key, : candidate ID, and then : mono increment. just to ensure that all of our keys are unique. And then we've loaded our CSV data. I accidentally hit enter here. I was going to do that right now, but the data is already loaded. So we load the data pretty quickly. This is a 250,000 items. And if I look here, some of the stats should still be there. You can see that it loaded in roughly 5 or 6 seconds at an average operations per second of roughly a little bit over 20 to 25,000. So this tool is still in developer preview, so we still haven't even optimized this for performance, but we do plan on making this as fast as possible and taking advantage of all the hardware that you have. So with that, I'll hand over to Eben, who will be showing Query Workbench.
All right, so I'm Eben Haber, and I'm going to be talking about the Query Workbench. Once you get the data loaded into your system, of course, the next thing you want to do is query it. Query Workbench is a feature that we put into Couchbase in release 4.5, but Nickel's been supported since version 4.0. And in version 4.0, we introduced the CBQ command line tool, which is a very good tool for writing queries from a command line, but it has some limitations. It's hard to edit very long queries from the command line. The output can be hard to read. Looking at one JSON document is hard enough, but looking at many is very difficult indeed. And there's little information on the buckets you have available or the document structure. So what I created was a web-based tool that's part of the regular Couchbase administrative UI that provides a multi-line query editor with syntax coloring, auto-completion, all the things that you want when you're writing a query. It also has a list of all the buckets you have available, and it can produce the output in several different formats. So just to view the different parts of it, at the top of the window is where you enter your queries. We keep a query history in the local storage of the browser, so all the queries you wrote yesterday should still be there in the day before, so that you can go back and run them again, or if you found that perfectly formed query to do a particular job, it should keep it around until you delete the history, so that should be useful. In the lower left, you have a list of all the buckets that are available in your cluster. And in that area, you can expand those buckets to find out what the schema is, and more on that in a second. In the lower right, we have the results from the queries that you've run, and you can see those results in the raw JSON format, but you can also see the data as in a tabular form or in a tree form. So I mentioned schemas, and if you've been paying attention, Couchbase doesn't actually support schemas. It certainly doesn't enforce them, but one thing you'll find is when you're holding business data, there are usually regular patterns in it. So there's usually common structure in those documents. And so schema inferencing is a feature of the query engine, and the Query Workbench uses this feature to select a random sample of documents and identify common fields or structures, essentially schemas. So in the particular example here, beer sample is a data sample that we ship with Couchbase. In this case, not knowing anything about the data before, the schema inferencing discovered that there are really two different kinds of documents, two different sets of fields found in this data set. And the first set of fields just so happens to have one value in common for one of the fields, that the type field happens to have the value brewery. It didn't know that the type field had meaning, but it keeps track of the different values of the different fields, and it said, oh, there's only one type for that field, so maybe that's a type indicator. Similarly, there's another kind of document there, another style of document with a different set of fields, and that one happens to have the type field beer. So this is very handy if you aren't completely familiar with the data. And once you've expanded this in the UI, you can use all those field names in auto-completion when you're writing queries. So you don't have to type the full name of the query. Or if you forget exactly how it's spelled, you can type the beginning and finish it that way. And finally, if you mouse over a particular field, it will show you sample values of that field that were found during the schema inferencing process. So you can know, oh, well, what format does that data come in? Auto-completion, if you type a partial name and hit tab or control space, it will show you completions that it knows about. And it shows you the default one, and if you hit tab again, it will use that as the completion. You can arrow up and down to select a different one. Now, as I mentioned before, looking at JSON documents, especially large complicated ones or large sets of them, can be fairly tedious or difficult. But these documents tend to have regular structure. So I created something that will render them as an HTML table optionally. And if you have fairly simple documents, that works. If you have nested documents, you'll end up with nested tables, but it's still oftentimes more readable than the JSON. The JSON spends a lot of space. It is very tall vertically. It spends a lot of space with the field names, and so a table can be a lot more compact. There's also a tree view, which is similar to the JSON view, but more of an outline list. So some other features, there's file I/O. If you have a query you really like, you can save it to disk. You can also save your query results. As I mentioned, there's a query history. It saves the queries you type so you can run them again later. It doesn't save the query results because they take too much space. And then finally, the schema inferencing that is used is a feature of the Nickel query language. If you use the infer command, you can get a lot more detail than is shown in the UI. So it will tell you if a field only shows up part of the time and what percentage of the time it shows up, and so on. Schema inferencing is kind of an interesting approach. You can use it to find how your data has evolved over time. You can use it to find dirty data if a field has different types in different documents, or if there's a field that only shows up a very small percentage of the time. Of course, there's some limitations. The UI does time out after 10 minutes. So if you're running a really long query, that isn't going to work very well. CBQ, however, the command line tool is much better for that, for scripting and for running long-running queries. Also, displaying very large query results can kind of choke your browser. Rendering that much HTML will cause your browser to come to a standstill. It does give you a warning and says, are you sure you want to show this much? It may take a minute or 10 minutes. But even if you don't tell it to render the data is still in memory, so you can save it to disk and use some other format for analyzing it. So now I'm going to move over to a demo and just show you. OK, so the query tab is right here in the middle of the administrative UI, and we can see, yes, we've got two buckets here. We've got contributions and expenditures. We're only going to look at expenditures, but we also notice that these are non-index buckets. The only query you can do on a non-index bucket is select count star, so that's not very useful. So I'm going to start off, and this takes about 30 seconds, saying create primary index on expenditures. And so I use my auto completion. Oh, let's see, and it would help if I, now let's see, there's an execute button in the upper left, but you can also hit enter after the semicolon to start the query running. While we're waiting for this to happen, I'm just going to go down here and do my schema inferencing to find out what the expenditures are like. So it says, oh, OK, well, let's see. I've got this thing. I guess that's a candidate ID. Maybe, oh, this looks like a candidate name because it gives me the sample values. And there's a disp amount, dispersion amount, and description. So OK, so that looks pretty good. I want to explore a little bit of the data here. So I'll say maybe select star from expenditures, saves me some typing. And I just want to look at small expenditures. So I'll say where the dispersion amount is greater than 0 and it's less than 10, and I only want a couple, so I'll just say give me the first 30 it finds. And now I've got a nice table here. So I can actually look at the data in a fairly compact format. I can look at the raw JSON. The JSON editor does have little arrows on the sides to let you expand and collapse objects and collections. The tree format is similar here. That's just an HTML list. OK, so now I've got a couple other queries I'd like to try. So Here's a query. I wanted to see how often the different candidates ate at McDonald's. So I'll just paste that in here, and I'll run it. And so what this query is doing is it's taking the sum of the distribution amounts, it's rounding it so we don't get some underflow, and it wants the recipient of the payment to start with McDonald, and it groups by candidate name, and it looks like Mitt Romney's crew ate at McDonald's 195 times and spent $17,000 there. Ron Paul almost as much. So, but you know, this query up here, it says, oh, that took 9.88 seconds, and maybe that's more the time than I want to spend running queries like this. But the beauty of Nickel is that you can create indexes. So I'm going to create an index on the first 8 characters of the recipient name. And so this is also going to take about 10 seconds to run, because as with the previous query, it was running a sequential scan over all the documents, not using an index. It's building the index here, but that should make my future queries run faster. So almost there. Okay, so, well, this time it took 19 seconds, but we'll save all that time. So now I'll go back to this query that I ran before. It took 9 seconds before. Now it takes 70 milliseconds, so that's pretty nice. And let's see. And I want to see, well, what's the same, and, oops, burger. I've only got the first 8 characters there in the index. I can do Burger King really quickly. I can see who was eating at Taco Bell, and so on. So, so as you can see, for doing interactive queries, exploring your data, this is a really nice way to go. But of course, a lot of times you want to run scripts, you want to run long-running queries, and for that, you want CBQ, and I'm going to hand you back to Isha to talk about CBQ. Oops.
I'm not tall enough to jump up, so I have to come around.
Okay, all yours.
So good afternoon, everyone. I'm going to talk about the command line shell. And so what's different? Firstly, what is the command line shell? It's basically a shell that provides an interface to the existing query engine and allows you to run a bunch of queries. It runs. Did you ask me to stop? Am I loud enough?
It is working, isn't it?
Is it? Can everyone hear me though? No. My voice isn't that loud, but I'm hoping everyone can hear me. Okay. Okay, so CBQ, command line shell that provides an interface to the query service. It actually, as of now, provides an interface to the analytics service as well, and that's going to be shipped with the DP for the analytics service. So there are 2 kinds of commands that you can execute with the shell. One is a shell command, obviously, and one are nickel commands, which are the nickel statements. When CBQ starts up, you have a bunch of options that you can give it, and these options will decide how your session is going to get set up, and we can come to that a little later. No. Is this better? Okay. Okay, where was I? Okay. So all of the options in CBQ are case sensitive, and all of the shell commands within a session are case insensitive. All of these different commands can basically be categorized into 6 categories, and you can see them up there. There's connection management, session management, shell server management, security, query, and scripting. We'll go over all of them a little bit, but if you want to look at them in a little more detail, I think all of our documentation on the shell has a lot of details. So connection management. As of the old shell could only connect to the query service, but now we can connect to the cluster as a whole. And it's going to auto-discover the existing query services for you in the cluster and round robin across them. So every time you fire a nickel query, it's going to round robin across the existing query services on the cluster. If you wanted, you could connect to a query service directly and have all of your queries go directly to that query service. You could also bring it up without connecting to anything and decide during your session how to flip around different query services. For security, we actually have different kinds of access, but for now I'll go over just some that exist in 4.5. We have role-based access. Sorry. We have role-based access where you can provide, say, admin roles. So you can provide username and password while bringing up the query shell using the -u and -p options. You can also provide bucket credentials using the creds REST API parameter. And basically, you can provide a lot of different things using our set and unset commands, but we'll go over that in a little bit. You can also have secure connections, because we have support for secure connections, so HTTPS, basically. Then you have session management, where you can set different parameters for your specific session, and play around with those based on what queries you're firing. You can also alias. Now, this is something that doesn't exist in that many database shells, but we have it. It's taken shamelessly from Bash. And it's basically you create an alias for a really long query, and you can run it as many times as you want without having to type out the entire query. So you just run the alias all the time. And then you have the history capability that Eben talked about. The difference being you can search through history. So I could say Control-R and then search through history for any query that I typed a while ago, and it'll allow you to go through shells. Query management, we have the ability, oh, what happened? Sorry. Yeah. Okay. So for query management, you can set and unset REST API parameters. For the Nickel service, we have a lot of REST API parameters, and so we can interact with that through the shell. You can run prepared statements. Now, this is something I think we still need to be able to support on the query workbench, but you can do it through the shell, and this is because you can set and unset query REST API parameters. And I'll show you an example of how to do that in a bit. You also have comments. So you have shell comments and Nickel comments. So you have block comments, where it's just like C, and you can put a bunch of comments within your /*//, or you can have specific shell comments, which are prefixed by hash and --. For shell and server management, you basically have a lot of shortcut keys. You can find information about your cluster, about your shell. You can edit all of the commands you saved in history. You also have the help command that's going to list out all of the commands you have within the shell itself. And then you can explicitly look up each command and find information about that command, examples on how to use that command and run it. Somewhat like a man page, but without having to exit the shell. So it's within the shell session. Then comes scripting support, and this is the most fun part, honestly. Files. So you can read a bunch of commands out of files and have them run in one shot without having to type them up again and again. And then you can redirect these into an output file. And this can be done both via options and via a shell command. The option is -f and -o, which is -file and -output. And the shell command is source and redirect. And I'll show you an example of that in a bit. You can also exit on error, which means exit the shell session on the first error that you hit. And you can also choose what parts of a query result to display. So you usually get this huge JSON blob when you fire a query. You can choose what parts to display and what parts you don't want to display. There are a lot of different functionality that's been added in to the existing shell. But since we're hard-pressed for time, I'm going to discuss just one. And if you want to know about the rest, you can look up our documentation. It should have most of them. So the one I'm going to discuss is how to run a prepared statement, because that's something most people who run queries use. And that's done using a couple of different things. I'm going to go over them. The first one is parameters. So in order to handle all of these different varied REST API parameters that the query service provides and allow for better scripting, we have 3 kinds of parameters in the shell. One is query parameters, which are all of the REST API parameters that Nickel provides. The second is session parameters, which can be of 2 types, which is predefined parameters, which can be something like batch, which allows you to run in batch mode, or hist file, which allows you to choose which file to store all of your history in. And then user-defined parameters, which can be any variable you want to set and then use later on in your shell session. And then we have named parameters. And named parameters is also a type of REST API parameter, but it's separate because it's a specific type of parameter. Every parameter has a prefix and a name, and this is so that we can distinguish between each type. All of these values can be set and unset using the set and unset command, and you can see an example there. So at this point, args is a positional parameter, and this is how you set and unset it. We're setting args to have 2 values, 1 and step 1, and this basically will refer to $1 and $2 within your prepared statement. And then all of the settings that Nickel can have via the REST API is settable from the shell using the set command and the prefix minus. So what do these commands actually do? So if you don't pass in any arguments to the set command, it's going to display all of the parameters you've set within your session and all of their values. And you can see an example here. At this point, since I just set the args command and it's a query parameter, it's going to be displayed below the query parameter. It's going to give you the value. And then we also have a predefined session parameter for this session, which is hist file. And that's where I'm sending all of my queries to. So that's where the history is stored, .cbq_history. The unset command basically deletes and resets all of the values for the input parameter. So I will go ahead and show you an example. So in order to define a name parameter, you prefix it with $. And so you have set $date to some date. And dates are treated as strings in Nickel. So that's what we have here. We have a date in the form of a string. And then for positional parameters, you set it just the way we saw before. And we've set it to that value. And you can set it to different values. The way you execute a prepared statement is, well, we have 2 kinds of prepared statements. In the first one, where you say prepare and then a Nickel query, it's going to assign a name to the prepared statement on its own, which is usually a UUID. So you need that UUID. Or if we're lazy and we want to give our own name, so we say prepare name from Nickel query, and we get a name prepared statement. And before we execute that prepared statement, we set all of these values that we've used within the prepared statement. And then when we execute it, we can, it uses the values that we set. So let's look at this. So if you can see the example, it's going to be the same example in the script I show you, but this is just the example I'm going to go over. So it's a short example of how you can script some queries using CBQ and the presidential campaign data that Mike showed you. When we look through the data, we can see a lot of large transactions involving 2 advertising companies. And it's not surprising, but a large amount of campaign money goes towards advertising. And what we found interesting was that the amount of money you can make from an election, especially if you're supporting the winning candidate, is quite a lot. Let me show you. Can I put this down? Because I'm going to put this down. One-handed. OK. So this is the script. It's, as you saw before, it's called example.nickel. And it's going to run a bunch of commands. They're both shell and Nickel commands. The first one is set, and I explained that a bit before. Then we have a comment that says, create a prepared statement to see which advertising companies made a lot of money. And then we have the prepared statement. So the name of the prepared statement is ADV amount. And the Nickel query is select card number sum. It's the same query that Eben used, I think, earlier, but it's going to tell us which advertising companies made a lot of money, and we can choose which candidate. So if you see in this line, you see that the candidate we're choosing right now is Mitt Romney, and the name, we're setting a name parameter minus $candidate to that value. And if you see up here in the prepared statement below, the recipient name and the distribution amount are positional parameters. So they say $1 and $2, and those values are set here. So $1 will be replaced with American Rambler Productions and $2 with 500. And then we execute the prepared statement. Now, we saw this entire thing for Mitt Romney, so we want to do the same thing, but for Barack Obama, and we do that again. So we just change the value of the candidate, we change the positional parameter values, and we re-execute the same prepared statement. So I'm going to execute this now. Let's just copy this. So the -f option is the input file, example.nickel, and the -o option is the output file, output.txt. So all of the result from this, from executing all of the input commands from example.nickel goes into output.txt. It's going to take a little while. Okay, so in the meantime, maybe I can show you. So this is usually where all of our so if you see, we have a lot of different options for a lot of, I won't go over them, but what we just used is the -f option, which is the -file option, and it tells you how to use it. And then if you go into a particular session, I can say /help. What? Oh, oops. There we go. So it's going to give you a list of all of the commands that exist. And then I'm a little lazy, so I'm just going to use that. And I'm going to say push. And it'll give me information about the command and an example as well. And I'm going to quit right now because I'm done with this. OK, so we see that this is done. If we look, we can see the output. And here we see it. So the set command just gave us all of the values that have been set. Then we saw the prepared statement, and it runs, and it gives us this huge, beautiful prepared statement. And we go down here, we see that we just set these values, and it executed the above prepared statement with the values that we gave in before. So that's the total distribution amount that they spent. And now we say, OK, so these are the values that exist right now. And we go down and we say, OK, now we want to look for Barack Obama. So we set the candidate name parameter to Barack Obama and the positional parameters to the other advertising company. And we re-executed the same prepared statement with these new values. And it gave us the value for Barack Obama. And now if we look at all of the values set, we see that the values have changed for both the positional parameter and the name parameter. So this allows for better scripting. I mean, there are more advanced commands like push and pop, because all of the parameters are parameter stacks. So you could have like a cascading set of values that you put in, and you don't have to, change these values. It just allows for developers to be a little lazier, which is nice. So, yep, that's about what I have for you. Thank you. If you have any more questions, I don't think we have time. Do we have time? Did I?
And then, so just to add, in case anybody didn't see, it was $223 million spent by Mitt Romney, and then it was $389 million by Obama. So a lot of money, and that's between two companies.
Yeah. You want to come up?
So are there any questions? Otherwise, we're all finished. Okay, thank you.